We're back with Module 4 CVP Analysis, M4-3 Cost Volume Profit Relationship and Graph. Let's start by reading the question. Orange Inc. manufactures a product which they sell to wholesalers and retailers. They have the following information for 2019. You'll notice that this is the exact same information we had for a previous video. I told you then that we were going to use Orange Inc. for the whole series of CVP analysis videos. Let's look at the required. What is the cost function for this product? Remember that costs behave in different ways, and understanding cost behavior can help businesses to predict how changes in sales volume will change operating income, which is why knowing the cost function, what it costs the business to produce the product at different sales volumes, is critical to predicting future costs. The costs are made up of both variable and fixed costs. It's important to remember that within the relevant range, fixed costs will not change as sales volume increases. At the same time, within the relevant range, variable costs per unit will remain constant, the same. If either of these things are confusing, please go back and watch my videos on fixed, variable, and mixed costs, and you'll see why this is true. To develop the cost function, we need to know the variable cost per unit, and we obtain that from this chart. Direct materials are a variable cost. Direct labor, variable cost. Variable overhead production is a variable cost. Total fixed costs. And variable selling and admin, variable cost. And then total fixed selling and admin non-production is a fixed cost. In order to calculate the variable cost per unit, we need to add all of the variable costs together. The sum of all these circled numbers, $27.50. For every single unit produced, it's going to cost us $27.50 in variable costs. We also need to know the fixed costs in total. The sum of the boxes is equal to $55,500. We also know this from the contribution margin income statement that we did in a previous video. Now we have the information to develop the cost function. Total costs are always equal to total fixed costs plus variable costs per unit times the sales volume. If we want to calculate a total cost function, we don't put the sales volume in. We know it's 3,000 for the actual level of sales for 2019, but we want to use a cost function to predict the future, so we don't put in a sales volume. We can now complete this by using the numbers we calculated. Regardless of the sales volume, we can use this formula to calculate total costs within the relevant range. To double check, we can calculate it using 3,000 units. If you look back at the contribution margin income statement, you will see that total variable costs are equal to $82,500 and total fixed costs are equal to $55,500. We now know that the cost function works. Let's move on to the next question. What is the revenue function for this product? The revenue function tells businesses what the total sales revenue will be at any level of activity or sales volume. It's pretty easy to calculate. Total revenue is equal to sales price per unit times sales volume. A short form would be, let's see if it works at a sales volume of 3,000 units. If you look back at the contribution margin income statement, you would see that sales revenue is equal to $150,000. Can we now combine these two functions to calculate total operating income? Remember that operating income is equal to total revenue minus total costs. Well, we know that total revenue is equal to selling price per unit times sales volume. Total cost is equal to fixed costs plus variable costs per unit times sales volume. Well, in that case, selling price times sales volume minus variable costs per unit times sales volume minus fixed costs is equal to operating income. We've now combined the two formulas in order to produce operating income formula. Let's put in 3,000 to see if it works. It should equal the operating income on the contribution margin income statement that we did in our last video. And what does this equal? This exactly matches the contribution margin income statement that we created in our previous video. We now know that this formula works. It should be highlighted that this function will work at any level of activity, as long as that level of activity is within the relevant range. We'll continue with this question in the next video. Welcome back. We are continuing with the video We're continuing with M4-3 cost volume profit relationship and graph. We're now answering part 3. The president would like to know what would happen to operating income at different levels of production, volume of sales. He says to you, I'm not a numbers guy. Can you show it to me using images or maybe a graph? Actually, we can totally graph what's called a cost volume profit analysis graph. On this graph, we would place the level of activity on the x-axis. In this case, the level of activity would be the sales volume from 0 all the way up to whatever we would want to, as long as it's within the relevant range. On the y-axis, we would place total revenue and total cost line. Both of these would be shown as different line items. Total revenue would be one line item. Remember, we would use the formula to calculate every point. The total cost line would use the total cost formula in order to calculate the line. Once we have these lines, we have a better image. I did such a graph, and I'll show it to you. Let's just talk about this graph for a minute. Notice a few things. The intercept of the total cost line. Let's just talk about this graph for a moment, and we'll notice a few things. So here's the graph that I produced on Excel. Note that you could produce this graph manually also. Let's just talk about this graph for a minute. Notice a few things. The red line is the total cost line. The blue line is the total revenue line. How do I know this? How do I know this? Because the total revenue line at 0 units is always at 0. But the total cost line at 0 units is equal to the fixed cost, which are $55,500. What does it mean when the lines cross? It means that total revenues are equal to total costs, and that means that operating income is equal to 0. This is called the break-even point. It appears that the break-even point is about, well, somewhere between 2,000 and 3,000. Notice the break-even point on the x-axis is number of units. Notice that the break-even point on the x-axis Notice that the break-even point at the level of activity is equal to the number of units that need to be sold in order to earn a 0 operating income. The break-even point on the total revenue and cost line is equal to the break-even point in sales dollars. Again, how much revenue you would have to have in order to end up with an operating income of 0. If sales volume is above the break-even number of units, what would that mean? For instance, our sales volume is 3,000. Where it intercepts the total cost line is the total costs at 3,000. Where it intercepts the total revenue line is equal to the total revenue, $150,000. The space between the total revenue line and the total cost line is equal to the profit earned. In this case, we know it to be $12,000 because of our contribution margin income statement. Let's imagine that we sell 5,000 units. Total costs at 5,000 units. Total revenue at 5,000 units. The space between the total revenue line and the total cost line is equal to operating income. The operating income that would be earned if the company sold 5,000 units. That tells us something important about the graph. Any number of units sold that is above the break-even point will always generate a positive operating income. What if sales volume was below the break-even point? What would that mean? Any sales volume that is below the break-even point would indicate the company was losing money. Why? Because the red line, which indicates total costs, is higher than the blue line, which indicates total revenue. If the president asks you, our product is a luxury product, in an account, what if the president asks you, our product is a luxury product, in an economic downturn? What if the president asks you the following question? Our product is a luxury product. In an economic downturn, how likely is it that we will stop making a profit on this product? Remember, right now we are making a profit. Our profit in dollars is equal to the space between the break-even sales dollars and the sales dollars we're making at 3,000 units. So how could this chart help us answer the question, in an economic downturn, how likely is it that we will stop making a profit on this product? The chart shows the margin of safety, or more precisely, the risk that the company is exposed to if sales volumes decline. The margin of safety is how far actual or budgeted sales are above the break-even point. On the x-axis, we can see that the space between the break-even point and the point we're actually selling at, 3,000 units, is the margin of safety in units. On the y-axis, it shows the margin of safety in sales dollars, which is the point between the break-even sales dollars and the sales dollars at 3,000 units. Remember that the margin of safety is how far actual or budgeted sales are over the break-even point. It shows how far sales volume can decrease before losses occur. In this case, we can see very quickly that the current sales level of 3,000 units is very close to the break-even point. In fact, it looks like a drop of just maybe 300 to 500 units will cause the company to start incurring losses, because the company in that case will be on the wrong side of the break-even point. The margin of safety allows management to determine how close the company is to operating at a danger level, and as such indicates their level of risk. The closer the sales volume is to the break-even point, the more risk there is that a small change in sales volume will move the company from a position of profit in the form of operating income to a position of loss. This graph is very helpful in showing the president the likelihood that, in an economic downturn, the company is at risk of losing money on sales of this product because they have a higher level of risk due to their lower margin of safety. Remember, actual sales is very close to the break-even point, and a decline in sales volume of between 300 and 500 units would result in the company suffering losses. In the next video, we'll actually calculate the break-even point in units and sales dollars. Thank you so much for watching. I hope you'll join me. Thank you so much for watching this video. I hope you'll join me in the next one.